Wicked problems are highly complex problems. They are unstructured, open-ended, they are multidimensional, systemic, and may have no known solution. In many ways, we can think about wicked problems as essentially dysfunctionalities within a complex system. Where we have the complex system of the human body, we have the wicked problem of healthcare. Where we have economies, we have the wicked problem of poverty. And where we have the internet, we have cybercrime. The concept of a wicked problem first derives from social planning and political science. Horst Rittel and Melvin Weber formally described the concept of wicked problems back in the 70s, contrasting it with tame, solvable problems. So let's talk about some of these tame problems first. Examples of tame problems might be solving a jigsaw puzzle, finding the shortest route from A to B on a map, or repairing a computer. These standard problems share a number of features in common. Firstly, they have a clear boundary. There is a well-defined and stable problem statement, which has a defined stopping point, that is, when the solution is reached. It is relatively simple to say what is part of the problem and what is not. Next, there are a finite number of elements interacting, and given enough analysis, we can fully understand the system, the drivers within the system, and the causes and effects. Think about fixing a car. It may be complicated, but there is a manual somewhere where all the parts and interactions within the car can be known. With tame problems, there are typically widely shared values and beliefs to the nature of the problem. Thus it becomes a technical problem, where there is a solution that can be objectively evaluated as right or wrong. And lastly, we're dealing with a static problem. It does not change over time. Think of fixing a light bulb. The actual problem stays the same throughout the process. Tame problems can be standardized. That is, they belong to a class of similar problems, which can all be solved in a similar way. And thus, we've developed a powerful and standardized set of methods within mathematics and engineering for solving tame problems, even when they're very complicated. Wicked problems are qualitatively different from tame problems, largely due to the fact that we're dealing with open systems instead of closed ones. Climate change is one of the best examples of a wicked problem, as is the challenge of global governance or multiculturalism. All of these challenges have a number of features that make them highly complex and non-amenable to our traditional approach in which problems are defined, analyzed, and solved in sequential steps. Firstly, because we're dealing with open systems, they are often unbounded in space and time. They cross disciplines, borders, and departments, making them very difficult to structure. You will often hear the word messy used by people when they're talking about wicked problems. They are also open in scope. The more you probe into the problem space, the more it expands into different dimensions. Unlike our tame problems, these wicked problems have no stopping rule. Terrorism might be an example of this. It slips through the fingers of powerful governments, and searching for its root cause will take you on an open-ended exploration of many different social, cultural, political, and economic dimensions. Wicked problems are multidimensional. Not only are they interconnected on many scales from the micro to the macro, they are also composed of multiple different social, economic, technical, and environmental factors. There is no one standardized global solution that fits all.